I want to give you one example for a battery aging matrix where you're looking at the health of your battery and you're cycling it. And as you can see here, right, like batteries degrade differently depending on what temperature they were cycled on, what the depth of discharge was, and so on and so forth. And you're really just trying to figure out, are they going to last the 3,000 cycles that you promised on average or not? And when you try to figure this out, right, like you start a bunch of cells on your internal test stand and you're wondering how many cells do I need to launch? 30, 50, 100, 150, 200. How many times do I need to repeat each cell test? 1, 2, 3 times? And so one of the sort of most useful things that you can do is you can use active learning as in our next test recommender to look at such an aging matrix and figure out what tests do I actually need to do to maximize my learning and build a really good aging model with as little money as possible. And so that is one solution. It essentially actively learns, and you can see this here in the video, what you should test from previous test campaigns to learn and apply in the next one. I'm not going to talk more about this today. There are already 5 webinars on the Monolith website where we have done this for hydrogen fuel cells, for battery aging, and for some other topics. So if you're interested in this one, have a look at this. What I want to talk about today is how you can shorten specific tests, or even better, how you can figure out when you're running your labs, if there's specific tests that you could potentially stop early and not waste your R&D capacity on running them for another 6 months because you're not going to learn anything special anyway, then this is a way of how you can actually, maximize the utilization of the limited resources that you have. So I want to talk about early stopping today. Very popular topic in a lot of battery labs out there. And there's a lot of myths around what's possible and what's impossible. And so I want to quickly jump over at this point into the Monolith software and show you how you can build a forecasting model. So the first thing that we've done here is, if you're not familiar with Monolith, we basically have this no-code environment where you import data, explore it, transform it, model it, and apply it. And here I have imported data from About Energy, where you have a variety of cells that you're cycling through different conditions and you're looking at the aging. You can see this on this screen. For this particular battery, we've run the aging tests at 0 degrees, 25 degrees, and 45 degrees. And I've seen this before. Sometimes in your engineering requirements, you start off saying, you know what, we don't need 0 degrees. We're controlling our battery to constantly be at 25 degrees. And so this is not necessary, but then you later on figure out, oh, hang on, we actually need to go such low temperatures. After all, let's add 0 degrees to the test matrix. And so you end up with your 0 degrees matrix being only half as progressed as the rest. And your engineering manager asks you to make a decision like, is it going to work for 0 degrees? Can we launch or not? We don't have another 6 months to wait for the remaining 400 cycles. And so you ideally would like to see what would happen with those based on the fact that you've already got 25 and 45 degrees and you've got quite a few tests. Could you learn from those tests to forecast the 0 degrees? That's something we've done in this notebook. So you have to do a couple of steps. I'm not going to go into the full details, but essentially what you do is you train a time series model, such as an LSTM, which is a type of forecasting neural network typically used for such battery forecasting applications. And you essentially train that on 25 and 45 degrees, and you forecast your 0 degree battery. You can see this here. We've validated the model down here. It sort of replicates the flow for the other batteries quite well, and then extrapolates this learning to the 0 degree battery.